Now, in this lecture, we will see how to write a program using 8255. So now in the last lecture, in the 8255 theory, I have explained that we can interface elevator, DAC, ADC, DAC, a traffic light, display, all those stepper motor, all those peripherals we can interface by using the 8255. Now here we will see that how to interface this. So first we will start with the basic program. So already we know that we can operate 8255 in two different modes. One is a bit set reset mode and another one is a IO mode. And again in IO mode, three different types of modes are there: mod 0, mod 1 and mod 2. Now here I'll explain one program using the mod 0, simple IO. Now to write any program, you should have a know how to write the control word. You should know that, and the control register has having address. Similarly, port A, port B, port C also having addresses. Now here I will show you the kit. This is the 808085 microprocessor kit. Now if you see this microprocessor kit, now here you can see the 8255 and one more 8255. Two 8255 ICs are given. Now for this one here you can see the socket, and here also here you can see the socket. Now here this kit I am using one more. This is one more 8255 IC. This is the demo kit. So now for that, directly to the 8085 by using this cable, this card, we are connecting this demo kit. Now here this 8255 is there. Now which 8255 we are using, accordingly we need to use the addresses of this control register, port A, port B, port C. Now here in this program, I am using this demo kit. So for this demo kit, the addresses are here I have mentioned. So these are the addresses for the demo kit. Now in this demo kit, what I am doing, now here if you see, this is the port A, red LEDs are called port A, yellow LEDs are called port B, and green is a port C. Here you can see 4 and 4, 4 and 4. Now total 8 pins are there. So here this is the VCC. Now from here you can make LEDs on, and here this is a ground. By using this ground connection you can make LEDs off, but without making without connection to the ground also, default it will show the off only. Now which LED you wanted to make it on, for that LED we need to connect the cable by patch cards like this. Now I have given the data like this. Now by writing the program, I wanted to, this is a port A. Port A, I have set some data, and that data I wanted to send to the port B. Or if you wanted to use to the port C also you can. But in this program, now whatever the program I have written, I have executed in this, I have used the port B. Whatever the data I have set on port A, I wrote in a port B, or I transferred to the port B. Now for that, how to write the program we will see. Now before that, you should know that how to write the command word. Now here what I am saying, simple IO mode means what? We are using this 8255 in a IO mode. So for that, what? The last bit, MSB bit should be 1. Now here if you see, if we put 1, this we are operating in IO mode. If this bit is equal to 0, we are operating in a bit set reset mode. And here I said that mod 0 means what? Here port A or group A bits are also 0, 0, mod 0 means 0, 0. And bit 2, here you can see port B, in which mode we are operating. Again, this is also mod 0, so put 0. D4 bit is what? Port A, either we are using it as an input port or output port. Now here if you see, I set some data on the port A, that microprocessor should read this data, and microprocessor should send this data to the port B. Means what? Now here I am using port A as an input port. That's why D4 bit as 1, and C port I am not using. That's why I'm making it as 0. Means what? C port, now I have taken it as an output port. But anyway, in this program, I am not using the C port. Similar now D1 bit is nothing but what? Port B. Now port B, I'm using it as an output port. Why? Because whatever the data is there on the port A, should transfer to the port B. Means what? Sending the data, port A data to the port B. Sending data to the port B means what? Port B we are using as a output port. And port C lower also we are not using the port C. That's why I have taken the 00. Now if you see, these are the bits for the command word. Now if I write this in a hexadecimal, so this first 4 bits I can write it 1001 is nothing but what? 9. And the next last all 4 bits are zeros means what? 0. So 90H. Now what is the command word? Command word is a 90H. And what is the control word is a command word or control word, both we can say, is a 90H. And what is the control register address? F3. So now to write the program, first what I need to do, command word, control word, I need to move into the accumulator. Now remember one thing, that so we can operate this control register ports, all ports only with the accumulator. So that's why what this control word need to move into the accumulator, and after that, that accumulated data should be sent to the control register. Now what is the control register address? F3. And sending the data is nothing but what? Sending the data instruction is what? Writing the data, nothing but what? Out instruction. Now in the accumulator, whatever the data is there, accumulator is where? In the microprocessor. Microprocessor accumulator is there. Now in this accumulator, microprocessor wrote 90. Now this 90 should be sent to the control register of 8255. This is 8255. In this control register is there. Now in this register we need to move. So this control register address is what? F3. So sending data to this control register means what? Writing data. For writing, what is the instruction? Out instruction. Now we have set the control register. Now after that, what? Whatever the data, this is manual setting. This is manually we are setting. So whatever the data we are setting, that should read, microprocessor should read that data. For that, what? In instruction. Reading means what? In instruction. Now where the data is in the port A. Then what is the port A address? F0. So in F0 means what? Whatever the data is there in the F0, F0 is nothing but what? Address of the port A. That will be read by the microprocessor. Now after reading means what? It is now available in the accumulator. Now again that value should be sent to the port B. Now port B address is what? F1. Sending the data to the port B means what? By which instruction we need to use? Out instruction. Now instead of sending the data to the port B, now if you wanted to send the data to the port C, anyway, in a control word, we made this port C also output port. Now the same control word you can use for sending the data to the output port C. Now here you have to use the port C address. Now after that, what? STS 6200 means what? Whatever the data we set on port A, the same data is now in the accumulator. That is, we are storing in the 6200. And after that, what? We are ending the program. So this is about the how we are using this 8255. So that's interfacing any device. Now here LEDs are interfaced. Now LEDs are connected to the ports, and how the data is processor is reading the data from the port and writing the data into the port. Now here I have taken the port A as the input port and port B as a output port. So this is the program.